In this section we'll be looking at impulse and momentum change, or momentum and momentum change. And this airplane is an F4, and what they're doing is they're colliding it into a barrier. They did this when they started building nuclear power plants in order to make sure that these barriers could withstand the force of an airplane. At the time they weren't really sure if that was ever going to be needed, but now that we've had 9/11 you can tell for sure that we need to know about that. The big question that you have to think about is which one of the two do you see here has more momentum? Well, let's say that the truck here is only moving at 1 meters per second and the butterfly is moving at the speed or very close to the speed of light. Obviously the butterfly will have more momentum. You have to be very careful that you understand the momentum is not just based on mass alone, but it's also based on the speed of an object. When we look at this very first statement, it just basically wants us to define what momentum is. Momentum is a measure of how hard it is to stop or turn a moving object. If you think about the characteristics of an object that would make it hard to stop or turn, two of them come to mind. The first one is the mass of the object, and the other one is the speed of the object. So for any one particle, we know that the momentum, P, and that comes from a Greek derivative, is equal to mass times velocity. Note that momentum is a vector quantity, and it has the same direction as the velocity. In college, if you take physics, you'll see that they will put little lines above the P and the V, or they'll have them in bold, as I do here. For a system of multiple particles, the overall momentum that you get, we could also do this, is equal to the sum of all of the vectors for each one of those particles. And the unit of momentum is the kilogram meter per second or the Newton times a second, depending on whether you're talking about impulse or momentum. Those can change slightly. For the very next thing, we have a sample problem. The sample problem should be very simple to do. Basically just says calculate the momentum of a 65 kilogram sprinter running east at 10 meters per second. Remember, our equation is momentum, we're going to put the little bar above it to show that it's a vector, is equal to mass times the velocity of that object. So this will be equal to 65 kilograms times 10 meters per second. We know that that direction is east, so when you multiply the two together you get 650 kilograms meters per second, and then you have to include a direction, and so that direction will continue to go east. That's the end of the very first section, or the introduction to momentum.